Okay.
I see some familiar names joining us.
Okay. Just let's give it a minute, then we can start.
Yeah. I think we can't hear our attendees, but everybody who's here, welcome to the webinar.
Yeah, welcome guys. Thank you for joining. Thank you for your presence here. Okay, guys. So let's start the webinar. Thank you for joining today. Welcome to the webinar, everyone. Once again, I'm Rahul Gaur, Director of Engineering at Innovasa, and I have with me today Varun Dhawan, Senior Director of Design at Innovasa. And I have been with Innovasa for last 6 years now. Varun has spent even a more longer period than me. So today we'll be talking about the design and technology interface, especially in the modern day front end application, what it means, especially developing such application for modern day healthcare systems. Over to you, Varun.
Yeah, thanks, Rahul. So just to set some context, like we are going to talk about like how healthcare has varying needs for design, and like over the past few years when we've been building products, we have been able to use JavaScript in general to be able to build a lot of these advanced interfaces. And before we dive into that, like I know a lot of you who have joined the webinar today might not have enough context on US healthcare and what we do. So I'll take just a couple of minutes to talk about that. Again, like we are a US healthcare company, all of our products are catered toward that. Um, and unlike India, in the US, all of the patient records are stored digitally. It's not a forever phenomena. Like I think it started to happen in 2009 under the Obama presidency, when the government made it mandatory to move from paper to storing patient records digitally. And that's about the time when vendors started to create this new software called EHR, short for electronic health records. And EHRs is what doctors use to store and retrieve medical records for their patients. Rahul, could you move to the next slide? So when we talk about EHRs, like EHRs aren't like great on usability. Like this is a screenshot from one of the leading EHRs. As you can see, like it's just a lot of data on the screen, and like imagine doctors when they are looking at their patients, it's probably just a 5 minute visit, and during that time they'll probably end up spending like a few minutes looking into the EHR, writing down information and things like that. So EHRs, when they were designed, they weren't designed to improve the relationship between a patient and the doctor. Their sole purpose was to feed information in the system. That information could be used in future for making better healthcare decisions. But like as a matter of fact, like doctors hate their EHRs because they just have to spend more time feeding them data. EHRs are like this data thirsty software that you have to constantly keep feeding, right? And and patients hate EHR too. Like what you have on screen. This is a painting that's supposedly been drawn by a 5-year-old when she was trying to describe her visit to the doctor. And what you'll see is that on the left there is this long back chair with the doctor sitting on it, looking into their computer. And on the right, there's this little girl sitting on the exam room seat with her mom. So that's the kind of situation there is in the exam room. Doctors are really spending a lot of time looking in the EHRs, and because of that, patients feel that their doctors don't listen to them. So there's definitely
Right.
this need to redesign like how the healthcare softwares work, and a lot of opportunity there.
So, so not just on the interface level, we hate EHRs too, man. They have just completely, fragmented the entire system, and it is such a, mess and difficult to deal with, unifying the data from a lot of different interfaces, bringing them to a central data, data lake or something. It is very difficult to build any meaningful application today, and essentially US is sitting on a very data mine of this patient data that has been logged for last from since early 2000s. And I wish only if somebody could put it all together into a good data lake in a good ecosystem, which would allow the application developers to develop application on top of that.
I know, and like when I talk to people and I try to describe what we do, I use this analogy where I say that it is like translating all of these different languages to English. Like we are basically like every EHR is talking a different language: Spanish, Chinese, German, and then we have to first translate all of that to English before we could even try to understand what like every EHR is saying. So that's kind of what we do. And like to your point, Rahul, I think like well said. Like somebody needs to put together this data in a right way, and that's pretty much what we are doing as well. So like what we are trying to do is create an ecosystem of tools and technologies where we can bring all of this data together in one place, so that then we can start to help healthcare professionals make the best use of this data, use this data to make better decisions when they're trying to deliver care to their patients. So like when we are designing it, we are basically trying to design technology that's simple, it's smart, it's unobstructive, and as effective as possible.
Right. So, simplicity is a prerequisite to building a reliable system. And basically, the building a simple system is not really very easy. So, however, there are certain guiding principles that really help you in developing a simple system, like abstracting the unnecessary or a complex part of the system, choosing the right abstraction, choosing the construct which basically generates a simple artifact, and defining the right kind of encapsulation there. So, yeah,
Mhm. Yeah, that sounds a lot like design thinking, right? Like abstraction, encapsulation. Like when we do design, we basically try to understand as deep as possible, ideate, uh, and then finally test and repeat, right? So I think that's very similar there. So like when you say simplicity, like I think simple can mean a lot of different things for different users. Like if you look at a data analyst, which is very well a user of our product, uh, the meaning of simple might be very different from them versus a doctor or a nurse, right? Because like analysts and engineers are more tech savvy than doctors or nurses. So like when we do our discussion today, I wanted it to be structured around these few different personas that are like big users of our products, and just talking about how we uh, approached design and technology differently for each one of them. So we have this like data engineer, and then when we onboard any new customer, the first thing that we do is we connect different EHRs. We pull data from all of those EHRs and these other systems, and we bring them to a common place so that we can then start to use it. And then, Rahul, if you can go back. So this is what the data engineers do. Data engineers spend a lot of time building these pipelines to bring the data, and then once the data is available, like there is a different user who is an analyst, probably like a master's in machine learning AI. They know how to use MySQL. They've spent time with like R, Scala, Power BI, and they now want to figure out trends from this data, build graphs, build models on top of it, and then the output of this model is eventually used by a doctor or a physician when they are looking at this patient. And then doctors, on the contrary, are not as comfortable with technology. They are limited to using EHRs and other systems in their work life. Of course, like personally, they would be using tools like Amazon and others, right? But like what doctors really want to be able to do is take best care of their patients and just want to make sure that they do the best they can so that like they generally have their star ratings up to date and things like that. Uh, so now these are basically the personas we'll focus on, and what you will notice is that like these personas and their interfaces have varying complexity, and then we'll explore how the solutions need to be designed differently for each one of them. So, Rahul, if you could move on to the next slide, I think it's a good time to dive deep into the first section
Sure.
of the webinar. So, I briefly touched upon the fact that we pull data from all of these different systems and bring it onto our platform. So, this is the product that's used by data engineers, and then when we were designing it, we explored existing tools like Airflow and uh, Alteryx, and like if we have engineers joining the webinar, they would be familiar with some of these tools as well. These are basically like tools to draw graphs and then like run pipelines. But these tools just did not cut for us because like we are just not trying to run any basic pipeline. We wanted to have a healthcare flavor to it. When we were pulling data and that data had blood pressure and heart rate values, we wanted to interpret those values as blood pressure and heart rate instead of just numbers, right? So we wanted to give them this interface which they could use to quickly drag and drop nodes and clean data, standardized data, instead of writing a lot of complex code. But we also wanted to make sure that simple things are easy, but they are also able to do complex calculations. Let's say they encounter a data that's not easy to manipulate, they could start writing code to take that data, transform it, and because we knew that they knew how to write in Python and they knew SQL, we were able to take that knowledge and design our interface to let them write those like scripts and codes. So there's a really interesting story about the time when Rahul and I we were designing this pipeline interface. Rahul, do you want to talk why and how we
Yeah.
decided this?
So, so being honest, like for me, it was at back then in 2015 or 16, if I recall, one of the most ambitious piece of UI interface I had undertaken so far. And first time I saw it, I was like, man, how the hell this is going to be developed? You know, but it was a very interesting journey, and ideally this kind of approach of this something like this, actually we developed this without using any third party library or whatsoever. But back then I think it was developed on in a vanilla JavaScript, and the math behind to develop this kind of graph or rendering is not more complex than any of those graph traversal problems that you have essentially read or solved in back in college, or as well programming practices and all that. So it was like very simple, straightforward. Two stacks. One contains nodes, and another contains the connections. And based on that, we basically render everything on SVG. It was using AngularJS, two-way data binding, so you could do any interaction, add some data, it gets updated in the data model. Yeah, it was like it's still like one of the very something very close to my heart, like something that I feel very proud of. It's
Mhm.
really amazing. And more than that, actually, I would like to touch base on why the need of developing such complex systems. You would have a lot of, on the engineering point of view, you would have a lot of tools or something. But let me tell you, like when you are working or basically tackling a real world domain businesses like healthcare, fintech or something, lot of those off market tools don't really cut in because there is a lot of domain knowledge that goes in that needs to be ingrained exactly like a framework or standard tool that you have been using. But yeah, it needs a bit more consideration than just a generic CSV parser or those kind of stuff. So the tool has to be tuned and has to be custom developed to cater to the data analysts, to data engineers who are working on the healthcare data, to be precise.
Yep.
Mm.
And like we did try those tools. I remember trying out a
Exactly.
few
Yep.
tools, and I know like our engineers, instead of being able to, like, since like there were multiple customers and they had to transform that data every time, they ended up keeping a copy of their code files in a place, and they were
Exactly.
using those codes and again. So like I
Exactly.
think
So that is my
a
experience with
well-solved.
Airflow as well. Like I have used Airflow quite a lot for a lot of data processing tasks and everything. Problem there is the same. Okay, it gives me a visual representation of a graph like thing, but then again it feels very limited, and eventually it also means like will be you have to develop lot of custom code on top of something like Airflow to orchestrate something like this. And if you are not using their default interface and everything, developing entire front end from scratch, then also those tools kind of lose their value proposition. So yeah, that was another point that I felt like this tool warranted the need to be developed at Innovator.
Yep, for sure. And like I think it's fascinating that we designed this in 2014 and the underlying framework hasn't changed. And I think that's
Exactly. Even
most,
I think the current version that we have deployed is on React, I think, but still it uses the underlying same model which I remember we developed while shipping the first MVP late at night at Investor in Noida office. That was a different time altogether.
yep, for sure. Yeah, I think let's move on. I think we've spent good time on it. Just like closing thoughts on that piece. Like I think when thinking about design, it's important to make sure that like what you're building as your MVP is something that you can continue to build on instead of just trashing it completely and then starting again. And then that brings
Right.
us to our like second section of the webinar,
So
and this is around.
before we go into second section, people who are in the room, guys, please ask your questions, and there would be prizes for the most exciting or most interesting questions that we have seen. Oh, thank you, Varun. Yeah, you can carry on.
Yep. You can put your questions in the Q&A section. So yeah, moving on to the next persona. So we talked about like another user of our product, the data analyst. And then when we were trying to build this module for analysts and data scientists, there were data scientists both at our customers as well as like internal teams who wanted to do this analytics. It was just fascinating to see the kind of questions they were asking versus what was available in terms of data and technology. So like these analysts, they just like simply wanted to get a list of all the patients who have diabetes and were in the age group of 17 and 60, right? But when we looked at the actual data, it just told a very different story. The data was almost like a table where you have two columns, diagnosis, like the diagnosis code and the coding system. So in the coding system, like when we are trying to understand like what does diabetes mean, they were like easily 100 to 200 different codes, and I put a screenshot there. So these are all of these different codes, and every one of them is eligible for a diabetic patient, and there are like a total of 70,000 codes. So even if you hurt your index finger, there is a very specific code for that. So like I think when we were designing a solution, it was important for us to think about a construct that was consistent with the mental model of our users. We wanted to let them say that they were looking for patients with a diagnosis of diabetes type 2, instead of them having to write every single code that they'll find in the data. And that's precisely why we designed this interface. Like we called it a measure builder, and then it has evolved into like a registry builder and a cohort builder, but the fundamentals remain the same. And like these users, we knew that they knew how to write MySQL, and like Rahul will touch upon that a bit, but like just being able to build an interface which is familiar to them is very important, right? So Rahul, like,
Right.
do you want to like share some
Yeah, so
additional
sure, sure,
information
sure.
there?
So as we discussed, like we have different kind of personas, right? So obviously this kind of interface is not something a doctor would like to use, right, to search a patient, right? So you need to understand for who you are designing the interface or the application or any piece of code, who, what, when, and how, basically. So keeping that thing in mind, our intent was to develop a query builder kind of an interface which is more generic, more flexible, and also leverages keyboard-based workflow more compared to mouse-based workflow. So what I mean by that is, just to give you a brief overview, generally, if you see in market, you have this kind of a rule builder which do the grouping and or not kind of thing. But the problem with this kind of tool is that there is a lot of mouse usage involved. Basically, for every rule, every iteration, you are using mouse. But if you think of the persona of the user, they are majorly somebody who's tending more toward the technical side. So you are not really leveraging the skill set that or the giving the experience that your users essentially basically are more familiar with. So to do that, our intent was to develop this whole thing as a uh, IDE of sort with a type ahead kind of a suggestion editor or something. Right. So I'll just quickly demonstrate like what I mean by that. So if you see here, I have this query builder thing, tool here, component, and I'll talk a bit about the component as well. So just to quickly give a demo. So here I have a rule set which is basically giving me a patient between 25 to 30 years of age. Let's see how this works. So, okay. So I have essentially changed the demography here, and now I'm going to do is add a condition for search all the patients who are between 30 to 45 years of age, and let's say how many of them have been diagnosed with diabetes. So yeah, so let me talk about this component here. Meanwhile, this code is being rendered. So this component essentially is developed in Svelte. It is a generic query builder, which is a basically you can think of as a modern take of this problem solving capability only, but in a more technically intuitive way for the power users. And so here you can see based on the whatever cohort or grouping that I am defined, I can get the set of data that I am looking for. Now to quickly, so why it was developed in Svelte? Because this and the other project that we just showed here, this measure builder, this whole application is in Angular JS, except this component, this is in Svelte. So this component, we developed it as a cross-platform, cross-compatible kind of a component, which can be plugged across different front-end application and provide you with the this kind of a declarative rule builder ability. One another interesting aspect about this component that comes to my mind is that how do you process this kind of expression. So to do this, what we did eventually, this is a JavaScript library called Nearly, which is a parser or a lexical, tokenizer kind of thing that you can, consider as. This allows us to define a grammar or a parsing engine, you may say. So here we have a very small parser grammar, which basically takes any string like this, which has a parenthesis, which are balanced. It has integers, and then it has some few keywords. So if it has any string has this kind of a balance expression, this library basically tokenizes everything into a component, which is what we are using in our view model to render that whole expression here. So if you can see this, yeah, this was also like very interesting and very challenging, use case that we solved essentially, and has been a very significant addition into our product, I would say.
Yep. And like if you go back to that demo, I think we still kept the ability to switch back to basic mode.
Exactly.
What's interesting
Exactly.
is that the first version we designed was actually an interface similar to the other
Right.
products out there, and we soon realized that like our users just found it too painful to click around all of these drop downs and check boxes to tell our product the kind of data they were looking for. Like this is legacy version of the interface from there, still usable by users who are not as tech savvy but want to be able to pull out this information. And just like users who are more comfortable with MySQL and type ahead kind of querying, they can always go back, switch to the advanced mode, and start writing in something that is more natural to them.
Yep. Actually, I was very much fascinated by this tool. Like when we were developing this, it was very intriguing and something quite, entirely new take on the generic boring query builder thing. So yeah, it was a very fun experience working on this project.
Yep. So yeah, I think there are some questions in the chat. Let's begin the third section, and then like we can come back to those
Okay.
questions in the meantime. So yeah, we are talking about like other third leg of webinar. So we basically uh, talked briefly about how doctors find EHRs like painful to use, and patients often complain that their doctors don't listen to them. And the reason is that when patients go to see the doctors, they are just busy looking into the EHR, trying to either pull up information from their past visits or entering new information into the EHRs. So we wanted to solve for some of that while making sure that if a doctor is required to do eye exam and foot exam for a diabetic patient, for example, they don't miss out on that, or if they were really supposed to prescribe a medication because it was required by the standard guidelines, they do not forget to do that. So that's where we designed this interface. It's kind of a slide out. If you have used like Windows or Mac OS, when you swipe on your trackpad from the right, the panel shows up, right? So it works in a very similar way. It's a canvas that slides out from the right side of the screen. Uh, and all the other time it's just behind the scenes, working in the background, trying to be aware uh, of the environment that's open on the doctor's computer. It's looking for the time when doctor opens up or searches a patient on their EHR, and then when it does, it knows that which patient has been looked up by the doctor by scanning this information from their screens, and it would then query our database, pull up insights that have been generated by the analyst and data scientist, and show that information as cards on the slide out. So like just very fascinating product. Like there is a very interesting insight about this that I'll come back to. But like I think on the theme of the webinar, Rahul, a question for you. I know we chose to build this product in JavaScript, even though it is a Windows application. So just why was that decision taken?
Right. So, so actually, JavaScript has come a long way in over last, uh, last decade, I would say, and kind of the functionality that we wanted to offer through this desktop application, cost of developing one native application of such scale or something would be much more taxing on us in general in terms of developer and learning curve and all those aspects. But like we were able to achieve more or less very stable, very smooth, and very good user experience with JavaScript only. Electron has become something like as a very good interface for modern day developers to bring their applications to native desktop platform as well. So we ended up leveraging Electron quite heavily. And another thing is that as a developer, I tend to prefer isomorphic stack. We as a people are very limited with our capability to learn new technology or master things. You can think of as like juggling balls. The average juggler can juggle 3 4 balls. Best juggler would be able to juggle, let's say, 9 10 balls. That's it. But you don't want to keep on throwing new complexity into the stack altogether. So that was also another reason. Like we were able to deliver, achieve all the business cases with JavaScript very efficiently. We were able to basically interoperate between the components and the design system, and a lot of those components back and forth between web and the desktop application. It offers a very consistent user experience in general. So yeah, that I can go on this, like basically why JavaScript is the best programming language in the world. But
Yeah, but
it's
like the JavaScript is usually used for like designing web applications and making API calls. Like how is this computer vision thing working? Like how are you using JavaScript to scan what's on the screen?
So essentially, the this node application is context aware through certain specific permission which the user has to grant it. It is aware of certain background application if they are open in the context, and it can take a screenshot of those areas and basically give it back to our OCR processing engine, which kind of analyzes it and identifies those text area and everything. And once it has that metadata, it can look up for that patient in our system and give that patient context to in note application here, and which essentially helps the doctor to get the information on screen without having to switch or pull for information.
Mm-hmm.
So that
Interesting.
is something, yeah, interesting aspect about this in note application, I would say.
Yeah. So when we like designed this product, like we thought it would be the best possible solution to just slide out in Node whenever doctors opened up like a patient on their EHR. But it was just surprising to figure out that doctors just found it very irritating and annoying because like doctors when they are on their EHRs, they don't just look like spend all of their time on this one screen. They keep switching around, so they use a lot of tools and just sections of the EHR itself. So InNode would just keep sliding out at the wrong times. So we had to soon
Okay.
figure out like how do we keep InNode like hidden while still communicating to our users that we had information available for this patient
Right.
that they were looking at. So it's just important how important it is to like stay close to the users and understand what feedback they have.
Right. So, Varun, would you like to give us a vision like what is the future of EndNote as an application? Where is it going, and in terms of technical evolution or extension, where are we going on with this?
Mm-hmm. Yeah. So like what you see on the right of the screen, it's essentially a blank canvas, right? And like what we have heard from our users and like other partners is that they want to be able to put more cards and more information on this blank canvas. So how InNode will evolve is this canvas where canvas and a marketplace where like other developers and companies can start creating cards and make it available on InNode, and then doctors and other users can choose which cards are more relevant for them, and they can turn it on or off. So that's the kind of direction we are taking. The idea is that we are able to create interfaces that are modular, and we can use them not just on InNode, but we could take these cards and show them up on different products. Like we have different products that are used by different personas, but essentially the information that they need is pretty much the same. So instead of having to design it again and again and having to develop that same piece of interface again, we want to be able to keep it modular and have it available for all of our applications. And I know, Rahul, like you have talked a lot about micro front ends and how they can make technology and like JavaScript applications really modular. Do you think these cards would be like micro front ends as well?
So if yeah, technically, yes, the cards are a micro front end. Essentially, micro front end is nothing but a modern day popular word for the very age old concept of developing isolated modules, a widget. And there is a talk by Nicholas Zakas. You can go back and check that on module theory, which essentially gives this whole principle that everything you develop is an isolated piece of component, a card, which exposes certain set of interface to interact with the host environment where it is placed, and so that it can easily take that component and move it across any other application context. It would work essentially fine as you intended to. So cards, what we are developing today, is a modern day take on that context only, and it builds on absolutely qualifies as a true definition of micro front end. But to understand that, basically, so typically you would it is not very straightforward to develop cards kind of micro front end, because in software, in software development, basically easy means something which is near to our understanding. And today we are familiar with developing modern day single page web applications, but the micro front end thing actually warrants a bit more of a understanding about your own business domain, what you are trying to do, and how you are decomposing your application. So let me just basically talk a bit about JavaScript before we understand like how this micro front end is going, and how the cards fit in as a micro front end. So JavaScript is a language which was developed in 10 days. Basically, it is a functional programming language, and all the web application that you see today, all the internet boom, the startup thing that we are seeing today, this web rise of all these massive IT companies, JavaScript has a very essential role to play in it, because post dot-com bubble, the modern day client side interface, and especially as with the browsers got more and more advanced, with JavaScript, like we were able to develop more complex interface which were more interactive, more intuitive, and essentially offered a better user experience compared to something pre-dot-com bubble where it was JSP, SPX rendered pages, full server rendered application with no JavaScript kind of thing for interaction. Most of those applications, and it was also very, not very easy to iterate on those applications. So with all of these things in play, like, and with the modern frameworks like React, Vue, and Svelte, it has become a lot more easy to design and develop complex interface with a much more ease than we would typically do, right? So, to getting to the problem that we were talking about, in general, currently in a front-end application, you can see this green box here, which is entangled with different kind of components. You have different components. Those components might look like a card on a visual level, but they are highly complected inside your application in such a way that it is not easy to place one component from one application context to some other context without extracting or boilerplating, duplicating the code, or rewriting it. So it is a bit of a messy way to do this. what we are essentially proposing with the cards is that each of these cards here have a dedicated or one or multiple service which backs that functionality. And now this entire functionality is basically end-to-end composed, and it has all the experiences that it needs. And this functionality can be placed across from to our web application or any other application where we want to consume this. So this gives us a bit more of a, I would say a more flexible kind of interface when it comes to, leveraging the engineering productivity in general. And
Mhm.
this essentially gives us a simplicity and ease of understanding. It becomes very tricky for a developer when they onboard an application, onboarding on a large single page application. It is difficult to understand or grasp the entire application, make changes or add features. But with this kind of approach, it is more easy and more basically, I would say, reasonable to uh, release any kind of a change in the system, and you have impact areas or boundaries essentially defined. If I have to talk about certain challenges, I would say this approach is not really maybe for everybody. It has a lot of benefit in terms of organizational scale and those factors, but then you run up into challenges like fragmented design, version inconsistency, and governance and organization model across application, because you have so many people developing component. How do you enforce all of them are abiding the same design and user experience in general? So I would say it is not for everyone, but certainly a very much beneficial from organizational point of view.
This
Yeah.
is quite fascinating. So is micro front ends a term you coined?
No, not really. No, I did not coin the term micro front end. It was something derived, with the whole microservices thing going on. People in the industry or in the community essentially came up with this term. But one thing people need to keep in mind, actually, microservices, micro front end, they share quite a lot of idea, but not entirely the same thing. Because when you talk about micro front end, you need to think, because see, microservices don't have a human users, but
Mm.
front end do have a human user. You can build it in so much of isolation, but eventually you will have to compose everything for the end user to consume or use that interface. That is where it becomes challenging, and it has some typical strict governance, what you can do in a micro front end and what you cannot do in a micro front end. Microservices might be more free or more forgiving of such constraint, that you don't have to think of this like how end user is going to be impacted.
Yep.
Yeah.
And I think as a designer, like what you're describing looks a lot like a design system to me. Like we are basically trying to build reusable components, organisms, and templates that somebody could just pick and reuse, or it's like its existence is independent enough so that you can just easily pull it out from one application and use it another, right?
Right. Actually, right. So actually, right. That is where we are heading to. We want to develop a machine which develops build machine or composes or interfaces like this. Actually, if you ask me, if you think of it, like today we have so much of analytics data inside, like we have in the patient world. We have so much of patient data, but not all of it in a strategically there in some single place or in a more developer friendly manner. So not many people are able to leverage that. Likewise, let's say with the micro front end, maybe the thing is that what we are looking for in the near term is that developers only focus on component driven development model. They just focus on one small entity or a component. They don't focus on the composition of multiple components. That is irrelevant to them. We have so much of A/B testing tools, such as Google Analytics, which actually we have so much heat map. We have machine which can analyze what is a best preferred user experience for me as a user. You could go to your facebook.com and see some different layout of a page, and when I log in I could see some different layout, because as per my preference, my usage, I would need some different component on the landing screen. And we don't need to, it is 2021, we don't need to do that manually today. We can
Uh,
essentially take a dynamic part to give a render the layout in terms of the user experience which is most suited for the end user who is viewing the application.
Mm-hmm.
Yeah,
Adaptive
that yep,
interfaces and all.
adaptive basically adaptive page layout or design system basically is what we are looking for.
All right, awesome. So we have some questions. Let me see. Let me like pick some questions and we can maybe talk about that.
Sure.
So there's one question which says, what is the thought process behind concluding that writing queries easier than drag and drop? And is it applicable for doctors, other staff? So I think this is referring to the registry builder or measure builder we talked about. And like the first version we created was actually a UI interface where somebody would have to click to add a new section and then use a bunch of drop downs and radio buttons to tell the system what are the properties of an operand, right? Because like if you think about a diagnosis, you'll have to either enter codes or search from an available set of diagnoses to specify which one to add. But just the number of clicks sort of add a delay to the actual thinking that is going in the user's mind. Like when the users who wanted to use this product were thinking about a problem in their head, the mental model was very different. They were thinking in terms of SQL queries because that's what they were used to. And like we wanted to implement something that was in line with how our users thought about these problems. So like what we ended up building was a flavor of SQL query. Like I think it still has some of those components. You could apply brackets. You could use just simple variables like age, gender, as you would in a SQL query. So yeah, I hope we answered your question.
So to complete that, is it applicable for doctors and staff, other staff? So generally, like what we talked about, right? If you take a look at the user persona, it will generally cater to analyst and maybe sometime data engineer might want to test it. But this kind of user persona would hardly be bothered by that tool majorly. What uh,
Yeah. There's a question, I think, Rahul, that you can probably take. Did we use anything like Niffy or Kubeflow for backend APIs? I do
I
remember.
think we have used Uzi previously. I remember recall, and then I think we moved to using Azkaban as a backend workflow processing engine to build this.
Mhm.
So the thing with Niffy and all was like they have a graphical interface, but as you can see, the kind of graphical DAG interface we wanted was very different from what a generic data execution engine DAG would like to present. This is a much more abstracted DAG interface, if you can think of it, and more catered towards the healthcare data engineers, I would say.
Right. Yeah. Jumping on to the next question, there's a very interesting question. So this person is asking if like if somebody has an accident, how would their information get to an EHR?
Okay.
Thanks Shashi for bringing this point. And like what's really interesting is that not all EHRs talk to each other, and that's pretty much why like we need a company and product like ours. So if somebody went through an accident, they'll likely be taken to an emergency department, and the emergency department would enter that information in the EHR. But when they go and visit their like family physician the next time, unless this person tells them that they had an accident, the physician wouldn't get to know. And
Right.
like what we do is connect to all of these different EHRs so that we have all this information about a person, about a patient available in one place. We call it the patient 360, and we can then take this information and provide it to like doctors so that they can make the best decision.
Fair enough.
Did you guys? I think we answered this one. There's another question. Should UX designers have good knowledge of JavaScript? Uh, I think it's not required
So,
at all.
but I
A
think
lot
it
of
really,
questions.
I think it really helps a lot. So Varun here prefers design, but is very good with JavaScript, and like working with him, I could feel that that bridge definitely helps a lot. Not to precursor, I would say, but something, yeah, definitely can help.
You're saying that it helps. Yeah, maybe. So, like, I think, like, more than just knowing how to write in a programming language, it's important to understand the thought process, like of an engineer, or how like programming languages work. You're trying to look for edge cases uh, in your solution, right? And like, you're just trying to deep dive. Like, when you look an interface, eventually it's going to be written in a programming language. It's like anything you do on a computer is eventually zeros and ones. But like, you don't need to understand zeros and ones, but if you understand how an engineer is going to implement your design, it's going to be helpful for you to predict edge cases, just dive deeper into your design so that it's more meaningful, it's more specced out. So that definitely helps. And like, my personal take is that you could do that by just working very closely with your engineers, instead of actually trying to learn programming languages. We have more questions. Someone is asking, could you please provide more information on the kind of work we'll be doing in life sciences? So, like, in life sciences, the kind of work is very similar to what we saw on the Measure Builder demo. Like, essentially, life sciences companies are companies who are either running clinical trials for a new medication, or are developing a new medication. So what they need is the ability to have a lot of data and figure out who are the right patients to start and involve in these clinical trials. So in life sciences, that's what we'll be doing, building tools that our customers can use to identify patients for enrolling in clinical trials. But because they have these tools, they could also see trends, like how many patients, like across a population, have a certain condition like cancer. Is it even relevant to build a new medication for a diagnosis that like very few people have? So those are the kind of tools we'll be building for life sciences. If I change my insurance policy, old EHR will delete, or it will carry forward like new policy? So EHRs are required to store data for like 5 to 10 years, and insurance is definitely a problem. Like, a lot of our users struggle uh, trying to figure out if a patient still has an active insurance or not. And like, I think more than a design and technology problem, or a design and interface problem, the problem is more about the flow of information from one source to another. And like, I think uh, US government, as well as a lot of companies, are trying to figure out how to solve that problem. But like, to answer your question, EHRs would have that information if somebody puts it there. And a lot of times, unless the patient comes back to the doctor after 6 to 8 months, they don't even know. Yeah, I think those are all the questions. I think we still have about 6 minutes. We can take more questions if anybody has any. If not, like, we can close this in a couple of minutes.
Are we hiring? Yeah, we are hiring, always looking out for the best talent in the market. You're most welcome to drop in your reference. Yes,
Yeah.
in other country have this kind of system. So I think US has the most mature, ecosystem and necessary things, precursors in place to leverage this kind of system. There is some scope in Europe, I would say, as well, and UK,
UK.
and yeah, in UK basically.
Mhm.
But so far, US is the most mature market. That is where our full focus is right now. Maybe in down the future, we would be developing for multiple countries, multiple places, definitely. What aspects of the security creating application for healthcare provider? So I'm not sure if I understand this question. Like aspects of accessibility, if you are talking about web accessibility guidelines, yeah, we are in a phase of being 100% compliant towards that.
Uh, Rahul, are you referring to this question on accessibility?
Yeah.
Right. Yeah, so like I can take that. So in terms of accessibility, like we are still only complying with the color contrast aspects of accessibility, which is part of the AA guidelines. Uh, but like healthcare is one industry that is starting to go big on accessibility. Like they want screens to be reader friendly so that people uh, can in general understand what's on the screen, and then definitely something we'll be working on in the coming years. The approach we are taking there is to build accessibility into our design system so that components as simple as input boxes and buttons are compliant with accessibility guidelines, and then eventually when we build like broader applications, they continue to stay compliant in general.
Okay. So I think I will have to like to answer this another question by Sudhir. I think why you guys reinvented the complete data pipeline. It seems Airflow can fit completely and Airflow community support. So like I said, yeah, we could definitely use any, not just Airflow, any workflow backend engine through its REST API to do that DAG orchestration thing. I think we are using Azkaban here to achieve the similar thing. Airflow is just a reference for the wider audience that on the visual context what this tool does actually. So it is a DAG for a more custom tuned for healthcare interfaces, and it has some abstraction. It is built on top of a similar workflow engine like Apache Nifi, Azkaban, or Airflow, the things that you are familiar of. We have a lot of overhead work done on top of it to make it more suited to our domain model, basically.
Mhm. Yep, and the goal there was to bring a healthcare flavor, and like often there is need for like healthcare functions and transformations. For example, like when we get data on blood pressure or just heart rate, like often systolic and diastolic blood pressures are in the same field. The field has both numbers and units. So some of those transformations had to be built because they were specific to healthcare. And what we did was we took Azkaban and built that flavor of healthcare on top of that instead of completely reinventing it.
Fair enough. So there is another question which I think is like wanted to know your approach in designing products meant for general public like Apple Health did, not doctors like in the case of PMS. So I would say we are also in the process of releasing application that is being used by general public or patients in that matter. Apple Health, what you say is like a I would say more of a consumer centric approach where you can tap in through certain IoT devices, basically get your data feed into a machine, basically Apple Cloud, and visualize that and get some insight on top of that. So I would say it is more of a assisted kind of application. Apple Health is majorly not being, your doctors might use their data from Apple Health down the line, but as of now it is majorly catering to the end users only. They can just they are more aware of their health status. I would say that is the proposition what Apple Health offers. Where we are, what the proposition we are offering, it is more of a care centric solution. How do you provide good best quality care to patient, to masses, and what are the decisions or what are the factors or how technology can help doctors in providing better care to the patient. So yeah, we would definitely do some consumer front applications as well down the line.
Mhm. Yeah, it's on the minds of a lot of
So
people.
there is this question: what is the philosophy behind growing current products and investor focusing on product discussed like in Note P360? Varun, would you like to answer this one?
Yeah, so in terms of the products, Patient 360 in Note, all of our products are essentially helping different users augment their workflows, just be more efficient with what they do. Uh, and a lot of that is basis on the data that we ingest. So essentially, all of these products work together, just the personas are different because their workflows are different. But like longer term, specifically for Patient 360 and Node, the idea is to be able to build them as platforms so that it's easy for us to build flavors of these products for a variety of personas. So, for example, Patient 360 could also become a provider 360. And similarly for InNote could be used by more wider audience and not just doctors, because we can then put different kind of cards on top of it. I think we are almost
Yeah, I think we are
2 minutes above
almost
time.
of the time. Guys, if you have a question, just post it on the event page or you can drop me on LinkedIn or Varun on the LinkedIn. We would be
Yep.
happy to answer you definitely.
Yeah, and we are definitely
And
hiring. I
yeah,
saw that as a question.
yeah.
So like if you are
So you
interested,
can check out our careers page basically, and yeah, definitely. We're always on look for best talent in the industry.
thank you for joining everyone. You have a
Sure.
good evening.
Thank you, everybody. Have a great day.